In this section, we'll be looking at an introduction to chromatography. In pharmaceutical analysis, we want to identify or quantify certain compounds. But many times, these compounds may not be in the pure form. They may be contained in a mixture. So chromatography is an important technique that we can use to separate these mixtures of chemical compounds into their individual components. Chromatography can be preparative or analytical. In preparative chromatography, we want to isolate and purify one of the chemical compounds that's present in the mixture. Whereas in analytical chromatography, we want to determine the identities of the individual components within that mixture. There are different types of chromatography, such as gas chromatography, liquid chromatography, thin layer chromatography, etc. But no matter which chromatography we are referring to, chromatography always consists of three components. First, we have the stationary phase, which is a solid phase or a layer of liquid that is adsorbed onto the surface of a solid support. The stationary phase does not move, that's why it's called stationary. Next, we have the mobile phase. So this is the phase that is moving, and it could be either a gas or a liquid. Then we also have the substances in a mixture that contains two or more substances that we want to separate using the chromatography. This image shows two types of chromatography, thin layer chromatography and column chromatography. Let's look at thin layer chromatography first. In thin layer chromatography, the stationary phase is a thin layer of plastic or aluminum or glass which is sprayed with silica. The sample is spotted onto the origin, which is over here. The stationary phase is then dipped into a mobile phase which contains organic solvents. The mobile phase will travel up the stationary phase through capillary action. As the mobile phase moves up the stationary phase, it also pulls the compounds in that sample along with it, but the compounds will travel at different rates. In this example, we can see that there are three different compounds in the mixture, compounds A, B, and C, and they get separated as different spots in thin layer chromatography. Now let's look at column chromatography. In column chromatography, the stationary phase is packed into a glass column. So the stationary phase here is silica, which is packed into the column, and an organic solvent is passed through the column. So organic solvent is the mobile phase. Here, the individual components are separated as bands, which will come out or elute out at different times during the process of column chromatography. To better illustrate how column chromatography works, let's take a look at this diagram. At the start, we have a column that is packed with the stationary phase. The sample is loaded at the top of the column. The mobile phase would be organic solvent, so fresh solvent would be added from the top, and the solvent is also allowed to flow through the column and come out of the column at the bottom. As the mobile phase travels across the column, it also brings the sample components with it, but you can see that the different sample components can move at different rates. So as time progresses, you can see the sample components A and B get separated, and the separation becomes clearer over time. At some point, one of the sample components will elute from the column, which means come out of the column, and it can be collected or detected. Then after another certain amount of time, the next component of the sample also elutes from the column. So what causes the compounds to separate in chromatography? The different compounds would have different affinities or strength of adhesion towards the stationary phase and the mobile phase. Affinity is, in turn, dictated by two properties of the molecule. Firstly, adsorption is how well this molecule can stick to the stationary phase. So if the compound can stick well to the stationary phase, it has high adsorption to the stationary phase, then the molecule will move more slowly during the chromatography. The other property of the molecule is its solubility, or how well it dissolves in the mobile phase. If the compound dissolves very well in the mobile phase with high solubility, then the molecule can move faster during the chromatography. But then what is it that causes the compound to prefer the stationary phase or the mobile phase? It is really the polarity of the compounds that is responsible for this. You probably have heard of the term like dissolves like. So let's say we have a polar stationary phase and a non-polar or less polar mobile phase. In this scenario, a polar compound would prefer to stick to the stationary phase because of the dipole-dipole interactions or hydrogen bonds. So a polar compound would then move more slowly since it prefers to stick to the stationary phase rather than dissolve in the mobile phase. On the other hand, if you have a non-polar compound, then the non-polar compound would prefer to dissolve in the mobile phase that is less polar, so it will then travel faster during the chromatographic separation.